Welcome, everyone, to another SDEC session. Thank you so much for joining us. My name is Adam Greco, and I will be working behind the scenes here to help out with any technology issues and to help moderate the Q&A. For those of you who are new to the SDEC, we are a free education community focused on the digital analytics and digital marketing space. We offer weekly free webinars from experts like Simo here today on a wide range of topics. If you aren't already a member of the SDEC, I will be posting information in the chat on how you can join. And the benefit of joining the SDEC officially is that you will be notified in advance of all of the webinars that we are doing, and you'll be invited to the SDEC Slack group where you could see recordings of past webinars. We have about 50 past recordings, and we keep growing each week. If you have any questions during this webinar in terms of technology or something's not working or a question about the SDEC, please use the chat and I will moderate that. But if you have questions for Simo, please use the Zoom Q&A. That's the best place. And you can put those questions in anytime. You don't have to just wait till the end. This session will be recorded. So if you want to share this with any other coworkers afterwards, they can join the SDEC and see the recording in the Slack group. One last note, I will let you know we only have about 2/3 of the SDEC members in the Slack group. So I'm going to be putting a link to easily join the Slack group. Some people just haven't been getting my emails. So I highly encourage you to join the Slack group so you can see all of the past recordings. So with that, I will turn it over to Simo. Thanks so much for joining us.
Hey everyone, it's good to be back. This is my second time around with SDEC, and I'm honored and feel very privileged to be invited back here to talk about something that's very close to my heart today. My name is Simo Ahava. I'm representing a company called Simmer, which is our new online course platform. And like I said, the topic of today will be something that's really top of mind for me over the last year or so. So we're going to be talking about server-side tagging in the context of Google Tag Manager. Just a very quick shout out that my company's online course on server-side tagging is taking enrollments at this very moment. And if you use the code SDEC21, you'll get a €50 discount from the course when going through the checkout. So check the URL teamsimmer.com for more information. Server-side tagging is and will always be deservedly compared to so-called regular tagging. So tagging that takes place in a website or tagging that takes place in a mobile app. And the way that this regular tagging works is that we have a tag manager of some sort running on a website or a mobile app. I'll be talking about websites mostly because the paradigm is a bit easier to handle in this context. But it could be DTM, it could be Launch, it could be GTM, it could be Insight, and whatever. They all work with the same principle. The idea is that vendor endpoints that the site needs to communicate with, whether it's for advertising reasons, whether it's for analytics reasons, whether it's for building audiences, collecting heat maps, whatever, the vendor endpoints are communicated with directly from the browser by deploying their scripts through a tag manager. So the benefit is that this adds a layer of abstraction on top of the website build, where instead of hard coding all these pixels into the website, you can use a tag manager instead, which kind of inserts those scripts dynamically on the website. But I think most people here know what a tag manager is. So I just want to focus on kind of why server-side tagging seeks to address some of the bigger issues that regular tagging has. So the most important part about how the kind of regular tagging paradigm works is that the browser communicates directly with vendor endpoints. So the browser sends HTTP requests to Facebook, to Google Analytics, to ads, to Adobe, and the browser represents the browser user here. So the user's fingerprints, the user's IP addresses, the user's behavior on the website is logged directly to these vendor endpoints. This means that the browser is typically communicating with content distribution networks. So when the browser needs to download something like the Facebook event JavaScript or the Google Analytics JavaScript, it loads them from Facebook and Google CDNs, respectively. And this means that the browser has to rely that the CDNs are trustworthy and that they respond accurately and with good time, because they are completely out of the hand of the organization sending those requests. They just have to hope that the protocol works. Another kind of offshoot of this direct communication with the vendor is the vendors start treating the site and the user's browser as a cookie store. So they drop first-party cookies. They might even drop third-party cookies or access third-party cookies. And while this is like at face value, there's nothing malicious about this. Cookies are just bits of information that are used to persist information from one page to the next in the stateless web. I think we all know that these vendors, especially who work in the ad tech industry, don't have necessarily the best interests of the user in mind when they drop these cookies. They want to be able to track these users from one site to the next. And these cookies are also a bit annoying because they increase the size of the request. They are included in all those HTTP requests. So when those vendors drop those first-party cookies into the browser, they are in fact making some damage onto the bandwidth of the user, as they have to be able to send those cookies with all the requests. And cross-site tracking is one of the phenomena that follows from these direct communications with the vendors. Cross-site tracking is something that I covered extensively in my previous SDEC talk on browser tracking protections. But cross-site tracking is one of those things that most browsers are determined to destroy and to get rid of and to neutralize. Safari in particular is heavily going after cross-site tracking vectors such as third-party cookies or link decoration and things like this. And cross-site tracking is a particular phenomenon uniquely addressing this, where the browser communicates directly with vendor endpoints. Tracker pings are things that the site sends. So it sends a ping to Facebook when a page view happens. It sends a ping to Google Analytics when a conversion happens. And these are requests that contain a lot more information than users actually think they do. So in addition to these anonymous cookie IDs, they contain a lot of fingerprintable surfaces. So not just the IP address and the user agent, but typically even some type of a hash that combines information about the browser's unique features, or maybe even in Facebook's case, a hashed email address, which is used to build those identities in Facebook's matching platform. And these are all things that the user is typically having a hard time to prevent from happening. And also, direct communications with vendor endpoints increases the risk of cross-site scripting attacks, because a malicious party could attack one of these vendor endpoints, maybe not Facebook and Google, but the smaller ones certainly, hijack their domain namespace and start delivering malicious scripts in those responses. Or they could kind of do social engineering and introduce scripts that look legitimate but contain harmful code, and kind of trick the site to downloading those instead. And then there's the kind of classic of our digital analytics genre is PII leaks. So whenever a broken form leaks the user's username and password into the URL, this is sent with the referrer string to third parties. In many cases still, even though browsers are actively neutralizing the usefulness of the referrer string. But PII is something that just seems to appear in browsers and seems to appear in analytics stores as well. I think everybody who's used Google Analytics knows of a case where email addresses have been collected due to search terms being collected, or maybe an event label somewhere or something else. So these are all kind of side effects of communicating directly with vendors by the browser. And this is what typical regular tagging does. And none of these are bad by definition. Well, apart from cross-site tracking attacks, none of these are bad by design, but they are all enabled by this stream of requests and responses with the vendors. It's very difficult for the site, let alone for the user visiting the site, to prevent or to control what gets sent to vendors and what vendors are allowed to do on the site. There are tools such as content security policies and sub-resource integrity checks, but these only take you so far. If the site wants to work with the vendor, they will allow a lot of weird stuff to happen in the user's browser just so that they can get a bit better data. So moving from this paradigm to server-side tagging and seeing how it addresses some of these things, because that's kind of my thesis here, is that server-side tagging is uniquely positioned to address all of those potential side effects. With server-side tagging, we still have those vendor endpoints. We still need to collect data to them. But instead of running a container in the website where these vendors are communicated to directly by the browser, the server container works as a type of a staging area between the browser and the vendor. So instead of the browser sending data to the vendors, the browser sends the data first to the server container, which then delivers the data to the vendors. And let's see what the benefits of this is. First of all, having this container that you own and control allows you to do unique hit validation. You can inspect all the incoming streams from the browser and validate them for data quality, for privacy, for different types of signals. So for an example I love to use is Google Analytics. Universal Analytics has this very weird way of ignoring hits that are badly formed. So if you try to send a non-integer value as the event value, for example, a string or a floating point, or a string is a better example, that hit will just be dropped. It just won't be accepted into the Google Analytics database. So, and there's nothing is reported back to the user or the browser. So what a server container can do is there could be a simple rule that if the incoming hit has an incorrectly formatted event value, then format it into an integer and then send it to GA. So it fixes the broken hit before it's dispatched to the vendor server. It allows you to do something called stream consolidation. So instead of sending an exactly identical data stream to Facebook, Google Analytics, to Adform, to Chartbeat, so an event happened, a page view happened, a purchase happened. Instead of sending the same bit of information multiple times with just a little bit different syntactic structure, you can just send a single stream of data to the server container, that says that an event happened, where it happened, by whom, and then the server container handles the logic of parsing this and sending it out to the different vendors. So in this case, instead of 3 requests, one to Facebook, one to GA, and one to Google Ads, you end up with just 1 request departing the browser, which means, again, lower bandwidth expenditure. For the server container, it means less network egress costs because there's only 1 request to respond to, and so on. So we have this way of actually improving the bandwidth impact and the amount of data departing the browser. Anonymization is a very nice thing that you can do with server containers. So even with these kind of anonymized IP parameters that you can send to Google Analytics and to other tools, the vendor will always see at the very least the IP address of the source machine, because this is part of the HTTP headers. And even though Google Analytics, for example, promises that the IP address will never be written in its full format into its data tables, which it's something that I have no reason not to believe, the IP address still goes through a number of gateways, a number of terminals before it reaches the final Google Analytics server. So there's a log of that IP address visiting, going through all these bounce trackers and all these different gateways. But with a server container, all the vendor will see is the IP address of the server container. So the anonymization becomes almost naturally, because the IP address of the source, which is the browser the user is using, isn't leaked to the vendors unless the server container is configured to manually do that. And you can do this. You can pass the user's IP address to Facebook and to Google, for example. But if you want to really respect anonymization requirements or requests from the user, you can completely eradicate any trace of the source browser, any fingerprintable data of the source browser you can eradicate with the server container. Consent management is something you can shift away from the client into the server. So instead of running those complicated consent management scripts that trigger logic, fetching those consent strings from third-party consent CDNs, you can just send store the consent string in a cookie and have the server container parse it and determine how it should be respected. This is a bit of a gray area when it comes to whether this is a pro or a con, because obviously many will see that moving anything to the server reduces transparency, and a big part of consent is to be able to verify that your consent is being respected. Client-side performance, there's obviously a big positive impact if you don't have to download those third-party JavaScripts anymore, if you don't have to communicate with third-party vendor CDNs anymore, because the server container can handle this through its own proxy mechanism. So instead of downloading expensive, like in terms of performance cost, expensive JavaScript from Google servers and Facebook servers, the server container can download these, cache these locally, and return minified versions or restricted versions back to the browser if necessary. Or you might not even have to use Facebook's JavaScript anymore at all if you're using a custom kind of data stream consolidation method, piggybacking on top of the GA4 request, for example, and using the GA4 data to send the information to Facebook. So there are big benefits and big gains to be achieved in client-side performance. And then there's this idea of tracking protection. It's not a typo, where things like intelligent tracking prevention are making it difficult to do even the basic analytics work because it restricts the usefulness of browser storage. So things like first-party cookies, the GA cookie, for example, is just not very useful anymore because it's capped to a 7-day expiration on Safari and all iOS browsers. But with a server container, you can use mechanisms that prolong the lifetime of these cookies. You can set them in HTTP responses. You can use domain names that haven't been flagged by these tools and so on. So it gives you tools to work around or at least work with browser tracking protections to a scale that client side just doesn't enable. So moving on to the kind of benefits and concerns, why do server-side tagging? Well, the biggest thing is that you have full ownership and control of the server environment. So you will get better control of those data streams. When Facebook JavaScript runs in the browser and collects data directly to Facebook servers, there's very little control you have except blocking Facebook's JavaScript entirely, which is obviously not an option for those who want to advertise on Facebook. But with the server environment, you have full control and you can strip out everything you want from those data streams. You can enhance them with API requests before sending them to Facebook. But the point is that you get ownership of a data stream that before wouldn't have been in your control. And server-side tagging for Google Tag Manager by default runs in the Google Cloud environment. So when we talk about ownership and control, you have to trust Google's promise that you own the environment. But if you don't trust it, it's a portable setup. You can take the container and install it in AWS, in Azure, even in on-premise if you so wish. The reduced client load means that you can start getting rid of that third-party JavaScript jungle, especially those related to event tracking or event data collection, because you can consolidate all of those and maybe just only have GA4 running on the site and then using the GA4 data collection in the server container to send the same information to Facebook, to Universal Analytics, maybe to Adobe, any endpoint that requires the same type of data. So you'll be able to start, this is an ongoing process. It's not out of the box. You need to start working towards this. But the idea is that you're reducing redundancy on the site and you're making a healthier content security policy as well. Every single domain added to a content security policy reduces the integrity of the content security policy. The CSP isn't supposed to have a list of 1 million different domains. That's not the point. It's supposed to be a gatekeeper preventing third-party domains from going rampant on the website. So with server-side tagging, once you start consolidating those data streams, and once you start proxying those library loads through the server environment, you don't need to have the third-party endpoints in the CSP anymore. You can get rid of googleanalytics.com, of googletagmanager.com, because you are able to handle this differently through your own server-side endpoint. Because it's running in the server, you can do things that you just can't do in the client. For example, handle API calls with secret keys, API keys. And this means that you can do things like data enrichment as well. So instead of, for example, instead of burdening the browser to collect a full spread of e-commerce data, for example, and sending it to GA from the browser only has to collect the transaction ID and send that to the server container. And then the server container can do an additional enrichment API call and fetch the rest of the transaction details, add them to the hit, and then send it to GA. So you do all this type of API enrichment stuff in the server container, and you can have those secret keys and credentials in the code, because it will never be visible to the browser, and the browser will never be able to take those keys and do malicious stuff with them. HTTP responses are, for some reason, a very underutilized feature of the protocol. And for example, Google Analytics doesn't do anything with responses. The GA tracker pings don't have a usable response. But with the server-side container, you can start adding information to responses, such as writing cookies as HTTP cookies instead, adding information whether or not the hit succeeded, even downloading a third-party JavaScript file like analytics.js and returning that back to the browser. You can even proxy the web Google Tag Manager container if you wish. There's a way to do that in the server-side GTM setup. But it's not all fun and games. Obviously, every single tool that server-side container offers for improving data governance, security, and privacy can be used to do bad stuff with. So the elephant in the room is obviously the ability to circumvent ad and content blockers, because those are still rely to a great extent on very clumsy heuristics where it's simply domain name matching and maybe request URL matching. So Google Analytics.com would be blocked, as would the request for analytics.js and gtm.js. But when you move to your own domain and collect the same data, maybe with a bit different path name, the ad blockers would not have your domain in their blocking lists, which means that you're effectively circumventing ad and content blockers. Now, I'm not one to start sharing my own philosophies here. People can do whatever decisions they like, but I firmly believe that using server-side tagging specifically to circumvent these things goes very much against what a user expects when they visit a site and have these technologies running in their browser. They expect to be able to block ad streams and content streams. They expect to be able to block analytics, and it's not our place to question their decisions or to interpret them in a beneficial way to our organization. So if the user is using an ad blocker, it's not our place to say that maybe they only intended to block ads, but not analytics requests. And this also means that by moving to your own domain namespace, the data collection becomes opaque. So the good thing about client-side tracking is that a user can look at the network requests and use audit tools, and they can immediately see if that data is being misused, if their consent is being ignored. But when you move to the server-side environment, this benefit disappears, because who knows what happens in the server? Who knows what those data streams will be manipulated into? So this means that a well-designed server-side tagging setup includes provisions for improving transparency. Maybe it means that your privacy policy becomes a bit more elaborate. Maybe it means that you use those HTTP responses to import upon the browser what just happened with the data stream, what kind of tags were fired, and things like this. This is still a part of a server-side tagging that isn't fully formed, and I'm expecting to see more developments in the coming months when people figure out how to improve transparency with this feature that is by definition not that transparent. Server-side tagging for GTM particularly has no built-in consent management system or consent management APIs. There's no way to decrypt a TCF 2.0 consent string, for example. So for now, consent management and handling consent strings strictly depends on custom coding. But hopefully, server-side tagging will have improved tools for deciphering user consent as well. Cost might be a factor for some. The default recommended setup costs around 110 euros per month, so around 130 USD. This is 3 App Engine flexible instances running, which is the recommended minimum. You can scale down if you have fewer than, let's say, maybe fewer than 1 million requests per month. you could scale down to 2 instances. It's always a good idea to keep at least one backup, because if scale up happens, it means that there's going to be a period of very high latency, and you want to avoid that. But with this 3 instance setup, if you start collecting more than 50 million requests, maybe more than 100 million requests per month, 3 might not be enough, and you might have to set 4 as the baseline, which will add an additional 30% to your monthly cost. But it's around 110 euros, depending on how much network traffic, how much computation you need, and how much logging there is going on. And there are ways to mitigate all of these as well. And then there's, of course, the poor availability of server-to-server endpoints. So it doesn't really help having a beautiful server-side tagging setup if the vendors themselves don't have a proper way to accept those requests. Well, all the big ones are in the game. So Google and Facebook definitely are already collecting those server-to-server hits. Google still has a couple of advertising tools, such as Google Ads and DoubleClick. Well, actually, I don't think they have any other advertising tools, but Google's advertising stack is still waiting for proper templates in server-side setup. But for example, Facebook's conversion API is already completely usable through server-side tagging. And I guess that once the big ones do this, and once server-side tagging becomes more and more popular, the long tail of smaller advertisers will also improve their endpoints capabilities. Third-party cookies won't work is the last kind of concern, or it could be a benefit, depends on how you see it. But because this is running on your own domain or in a custom domain that has nothing to do with the vendor, it obviously means that third-party cookies set by the vendor won't be able to be read. So any advertising or marketing scheme relying on third-party cookies will not be made automatically functional just by virtue of going to server-side tagging. So other means of collecting that cross-site data have to be introduced. And Facebook obviously tries to get more and more sites to use the hashed email, for example. To get things started for the Q&A, I'm going to ask myself some frequently asked questions, because these seem to be popping up all the time. So the first is that I hear all the time is, does this replace client-side tagging? So this is not a replacement, it's a complement to client-side tagging. If you want to measure things that happen in the browser, you still need something running in the browser. A server-side tagging runs in the server, and it digests a stream of events that comes from someplace. But it does complement client-side tagging in that you can add those enrichments through those API calls. You can store that data into your own data warehouse through different APIs and so on. So it adds an additional layer to tagging. But if you want to collect information from the browser, you need JavaScript running in the browser, unless you're satisfied with server logs. But these obviously don't have enough information for many of the behavioral analytics needs. Is this server-side tracking? Well, no, the Venn diagram overlaps somewhat. A server-side tagging setup can also be used for server-side tracking. So server-side tracking in a traditional sense is a tracking scheme that happens purely in the server. So either between servers. So for example, your sales engine sending conversion data directly to Facebook, or something like that. Or it could be things like parsing server logs and storing them in a server-side database. That's server-side tracking. But server-side tagging can it can handle those data streams as well that originate in a server, but it can also handle streams that originate in a client device. So it's kind of overlapping Venn diagrams in a sense. Is this legal? Gets asked quite a bit. Obviously, the move to a more opaque data collection adds an additional pressure to legality. And all the tools that I've introduced here can be used for legal things. And perhaps by virtue of being in the server, it's easier to do that illegal stuff and get away with it. But this doesn't change the dynamic anyway. You still need consent in the EU if you're handling personal, or you still need a legal purpose if you're handling personal data. You still need consent if you're dropping cookies, or at least a definition of a strictly necessary cookie in the EU. This doesn't change that equation one bit. Just by moving to your own domain namespace, so instead of sending the data directly to Facebook, but first to your own server container, doesn't change thing one bit. You're still handling data, and you're still forwarding potential personal data to vendors. So the requirements for those data streams doesn't change one bit. In fact, you're just more pressured to be transparent and have a good privacy policy and have good terms of use, and a good legal department if you want to start using server-side tagging. Is it future-proofed against ad blockers and tracking protections? Well, nothing is future-proofed against these, and the browsers with their tracking protections are just moving forward at light speed, trying to quench all the vectors that enable harmful forms of user tracking. But server-side tagging, at least for now, does give you lots of tools to improve data quality and get some of that data back that would otherwise be lost into cyberspace because of tracking protections and maybe even because of ad blockers. So currently, server-side tagging is fairly resilient to these means, but it's by no means immune to them. How do I migrate a tag to server-side tagging? That you can either build your own custom template for the tag if it doesn't exist yet, or you can wait for others in the community to build it and for it to appear in the community template gallery. So the community template gallery will at some point include all the server-side templates as well, making it easy to send that data to your preferred vendors. And where can I learn more about this? Well, here are some resources. So I'll make sure that you get these slides. And I just want to mention one more time the course currently accepting enrollments on Simmer. So if you enroll with SDEC21, you get 50 euros off the course enrollment. And that it's going to be a very good course. I'm very proud of it. And that's my 30 minutes and change up. And I look forward to seeing what's going on in the Q&A. Thanks for attending.
Awesome. Thank you so much, Simo. So our Q&A is blowing up. Normally, I like to go through them and kind of pick the ones that seem to be out there, but there are so many that you covered so much. I might ask your help to kind of just pick through them, the ones maybe you might be able to kind of scan them and consolidate. I might just have you go after them yourself because they're coming in faster than I can read.
Sure. All right. So let's start with the first one because this is an easy one. So by applying anonymization when sending data to the vendors from the server container, do we lose the user geolocation for that hit? If geolocation is based on a reverse IP lookup, as it often is, yes, this information will be lost. However, there are ways to get it back by geolocating the user yourself first, and then adding those geolocation strings to the outgoing request. And server-side tagging actually has that information in the App Engine headers directly. And I've actually written an article about this, how to get that geolocation information back without having to send the user's IP address to Google. Does server-side tagging potentially impact tag fires or page performances? It sounds like a server container functions as an extra step for all HTTP requests and responses. So it doesn't impact page performance. It's the exact same step that just instead of sending the data to Facebook, the data is sent to your server container. So all things being equal, it's the exact same performance cost. However, you can start doing that data stream consolidation and you can start combining those data streams, in which case you actually get an improved page performance, because instead of sending all those almost identical HTTP requests to different vendors, you just send a single request to the server container and then the server container fans it out to those vendors. It might mean that you might see a bit more latency between the hit reaching the vendor versus sending it directly to the vendor. But in my experience, this has been pretty negligible. And it just means that you might not be able to run a beautiful real-time system with server-side tagging unless you invest a bit more in the computation. There's a very specific question about the conversions API event source URL, only 90% of them coming across. I can't help you with that. By looking at your question, it looks like it should work. I don't know why it would be null. I have no answer for you in that case. I would take a look and try to replicate the problem, try to reproduce it, and then it's easier to attack it. Failed to pick backend. Yes, it sounds like a load balancer error. Again, it could be due to a number of different reasons, so I can't debug this for you here and now, except just to recommend to go through the Google Cloud Platform logs and try to find find the culprit there, in the load balancer logs especially. Um, if you do a server-side implementation, can you see the network traffic still in the DevTools of the browser? You can see the network traffic to the server-side container, but you can't see what happens in the server-side container. And this is what I meant with the opaqueness and the lack of transparency. So you'll be able to see that page view hit departing the browser to the server container. But if the server container decides to take this page view hit and send it to Facebook and to GA and to Google Ads and to Adform and to Criteo, and a million different places, none of this is visible to the browser. So this lack of transparency is a bit worrying. And how do you test these implementations? Well, there are tools for adding monitoring to a server-side container. So if you have control over the server-side container, you can create your own monitoring tools. You can do the same type of tag firing monitoring that web containers let you do, and so on. But a very good question, and unfortunately, just one of kind of the collateral damage of server-side tagging. I'm going to skip the question about observe point. I haven't used it enough to be able to tell you. Then we have, what do you suggest for tracking interactions and data points inside the internet banking section, server-side tracking or client-side tracking from security and transparency perspective? Oh, this is a very difficult question to answer, because obviously it depends so much on the legal frameworks that apply into whatever region you're working in. I wouldn't say that there's a hard and fast answer to this. I would think that not having those third-party libraries is a definite plus. So not having to load Facebook's JavaScript or Google's JavaScript or any other JavaScript files in that internal section improves the odds of data leaks not happening. So a server-side tagging setup could be very useful here, as you can really make sure that the vendors only get anonymized data streams. But the transparency requirement is a bit problematic here as well, because you also obviously want to be able to tell your customers exactly what happens with those data streams. But on a technical level, I think it is a benefit to look at server-side tagging in this scenario. Can you provide an example of how and with what you can enrich data on server before passing it to the vendor? So I gave an example of transaction information. So you can only, collect just the transaction ID from the browser and then pull an API in your sales engine or CRM with the transaction ID, fetch the rest of the transaction data, and then send it to the vendor enriched. You can do things like IP lookups. You can do things like PII malware checks. Any kind of API, there are a billion APIs out there that can do things with HTTP traffic. Publishers would love server-side tagging because all they have to do is send the content ID to the server container, and then the metadata, metadata APIs can be used to pull in authorship information, categories, tags, things that are typically difficult and cumbersome to handle in the browser itself. Unless you're a very technical marketer, this will require marketing plus dev to work closely together. Do you have tips on how to brief development about what is needed? So the cool thing about server-side tagging is that it is still very Google Tag Managery. So it is completely, and I obviously it's a biased claim from me, but I completely believe that anybody who can use GTM can deploy a server-side container. You don't necessarily need IT and dev, other than for making some of those DNS changes so that you can introduce the server-side tagging endpoint into your own domain namespace. And there is no data layer anymore in server-side. The paradigm is very different. There is no, the devs don't create an object in the server container that is used by the tags, because the server-side tagging is simply a proxy. It takes in requests and it passes them forward. So there's very little setting up. You just need to install those clients and tags into the server container, and that happens completely within the UI. So I think, again, I might be a bit blinded by having been so knee deep in this subject for so long, but I think that this is one of the easiest ways to get started with things like cloud engineering and infrastructure IT infrastructure, because you can do all this stuff without having to get into the weeds. And obviously, it's a great thing to keep IT in the loop and keep the developers in the loop, but they aren't bottlenecks in this scenario. You can run this quite easily without having that oversight. Can we track analytics of a PDF page where a user lands from an external link directly, such as link available? This isn't something that server-side tagging solves. This is something that server-side tracking solves. So you need some way to parse through those server logs, see those PDFs being requested, and then send that data forward. Server-side tagging wouldn't be the system for this, but you would need something that basically a server log parser for those PDF requests. How can Facebook reliable audiences be created if we remove the fingerprinting by sending it via the server? Well, this might not surprise anyone, but Facebook has a million different ways to, to handle that identity. So obviously there's the FBC and FBP cookies that are still sent to the server if it's a first party, if it's running on a subdomain of the website. So that's not a problem. FBP and FBC, so the Facebook click ID and the Facebook, I'm not sure what the P stands for, maybe persona or something. Those cookies are still sent and can be used. Then obviously there's the hashed email option. There's other user data parameters, first name, last name, country, all these kind of really shady parameters that Facebook would love you to use. So there are all these different parameters apart from fingerprinting, but they just require the site to send them, and they obviously require a lot of consent and a lot of red tape to be allowed to be used. There's a discussion about Telium, Event Stream, and GTM server side, and I'm not qualified to answer that question. I'm glad to see there's discussion going on, going on in there, and I can't tackle that. So thank you for people who are helping out with that question. Data encryption to be sent to the server is done at the client side, or data are sent in clear HTTP headers? That depends. You can choose how you do it. You can encrypt anything you like in the client, or you can send it plain text. This server side tagging doesn't care. You can choose the level of obfuscation you want to employ. Do you want to send only hashed content? Do you want to send base64 encoded content? Do you want to send encrypted content? Do you want to send plain text? It's really not, it's like anything goes, and you can build the clients and the parsers in the server-side environment to handle all these different use cases. Do you have any insight into how far along other TMS vendors are with regard to server-side tagging offering? I have no idea. I'm a one-trick pony when it comes to this stuff. But there are people in the SDEC more qualified than me to answer that question. What is the right moment to switch the server-side tagging? Whenever it works for you. I mean, let me put it like this. It's a technology that requires a problem before you implement it. So don't jump to it just because I think it's a great idea. The right moment is when you have a need for all the benefits the server-side tagging offers you. It is a production-ready solution. There are huge sites out there running it right now, and it works just fine. There are some hiccups, but Google is working a lot in the first couple of quarters of this year to fix those. I'm really sorry if there are questions below that I'm never going to get to, because I'm just going through in this order, but let's see if I can then tackle some of them in the SDEC as well. If you track client side with GA4, which has a user ID, then how do you set the user IDs for all your vendor tags when they might be a different format? You need to start managing some kind of a map in your server-side container that will map those user IDs to the formats that the vendors require. So this is, again, something that server-side tagging doesn't restrict or enable specifically. It gives you all the tools that you need to build those maps and to share those maps. One other option is that you can send all the vendor-specific identifiers as extra parameters in the GA4 request. Reserve a namespace in those parameters, such as Facebook-ID or Criteo-ID, and send it kind of as an event parameter. And then in the server-side endpoint, take those custom parameters and use them for the vendor endpoints, and then just remove them from the GA4 request in the server container. So this is one way to handle the data stream consolidation when you need really like vendor-specific information to be collected. What's it like trying to build and debug server-side tagging implementations versus client-side standard setups? Um, it's different for sure, because you are not collecting data itself. You're not adding click triggers and things like this. You are simply building request parsers. You're building these parsing machines that expect a certain type of request to come in, and this request is then parsed and sent to vendors. So it's a very different mindset. The assumption with the server-side tagging setup is that some other tool out there does the actual tracking, and then the proxy, the server-side proxy, just handles the mapping and the dispatching outwards. So the mindset is completely different. As I said, it doesn't replace client-side tagging, it complements it. So you still need a robust client-side setup if you want to measure things that happen in the client. Do you have a list of analytic solutions which offer server-side tracking? No, I don't. But well, basically any solution that offers a pixel request option, so where you can send the data using an image pixel, those are trivial to move to a server-side setup. And that's a large number of advertisers and analytics vendors out there have the pixel option, because replicating that in the server is trivial. Obviously, you need, if the advertiser requires, or the analytics vendor requires, third-party cookies, then this won't work. But hopefully the community template gallery will be soon open for server-side tagging, and we'll be able to see all the vendors who already have submitted templates. I know for a fact that Facebook is working on official server-side tagging templates, so that's pretty exciting. And yeah, let me see. Here we go. We currently use Universal Google Analytics for our website analytics. Last year, we suffered a bot attack that skewed our website analytics. Could you talk about some possible solutions to prevent this happening again? Okay, so this is very interesting. So fraud detection, spam detection, bot detection. Currently, there are no built-in tools to handle this in the server container, but I believe this will be one of the more industrious parts of server-side tagging, where new templates will be introduced, new malware protection methods will be introduced that help with this problem in particular. But currently, nothing does exist. But this is, again, something that APIs already exist for, so it would be interesting to see if, for example, the malware detection capabilities of Google Cloud could be introduced into server-side tagging. If I have server-side tagging set up, can this still be controlled by content management platform? I think I mentioned this already in the talk. It's a bit difficult for now, but hopefully soon we'll have built-in APIs for handling that stuff. I'll just click some of these done. I can see that Adam is also moderating. I have time for maybe 2 more questions, and then I have to go and help my son put on his jammies. But like I said, I'll try to, maybe if Adam can get the log of questions, and I can kind of tackle these in the
Yep,
education.
I'll be giving you a spreadsheet, so if you can kind of
Excellent.
remember which ones you already answered, you can send me the answers, and I'll post it to the Slack group.
Yes, perfect. All right. So 2 more questions. Let's see. This is good. You mentioned the piggybacking GA4 to send data to Facebook. Can we pick up event behavioral data for unknown users as well and send those to Facebook, other sources on top of GA4? Yes, you can. So like you can take that GA4 output and send that information to anywhere. Obviously, whether or not the vendor can make any use of this completely anonymous data stream is another question. I believe that Facebook can make use of conversion data even without almost any identifying parts. The matching ratio just goes down, but I would assume that Facebook can do some modeling with that information. I don't know, but other vendors certainly can make use of that event behavioral data as well. You could send it to, maybe even Hotjar. I always blank out with examples when I'm supposed to give examples of analytics platforms, but there are, many platforms that use almost the same identical syntax, Snap, Pinterest. They all care about page views, purchases, adds to cart, initiate checkouts, because they all model after Facebook, and all the analytics platforms model after Google and Adobe, for example. So there are many platforms that you can send the data. Okay, this is one. This is a good one. For the last question, Kevin's, can you go over your HTTP responses bit again, please? How can they be used, and can you explain a bit more detail how preserving the GA cookie works? So I'll explain the second part because that's a bit easier for now. So ITP, Intelligent Tracking Prevention, restricts the lifetime of cookies written with JavaScript. So when Facebook and Google Analytics and Adobe and other libraries download on the site, they set a cookie with JavaScript. And Facebook truncates the expiration of these cookies to a maximum of 7 days. But you can set cookies with HTTP responses as well. So when you send a request to a web server and the web server responds back, that response can include a set cookie header, which tries to set the cookie on the domain of the web server. And if the web server is running on the same domain as the website, then it's a first-party cookie, and ITP doesn't restrict the lifetime of these HTTP cookies as long as, and this is a technical detail, as long as the endpoint DNS is handled with a direct IP address record, and A record is the name of the record. If you use a C name record, which is a canonical name record and is popular among analytics tools and advertising tools, then ITP will truncate that as well. So you need to be careful when setting up server-side tagging to make sure that it runs with A records and not C name records, and then you'll get your cookie lifetime back. There's no promise that this will be indefinitely a good way to do it, but it is, from a technical point of view, it is extremely difficult for Apple and for other browsers to start delimiting the capabilities of these A records, because they point to IP addresses, and IP addresses are difficult to pin to a single vendor. So hopefully these answers have been. I think we have more questions left than what we started with, which is pretty pretty cool, but also a bit worrying. Just quickly, the question was, what was the discount code? Yes, this SDEC21 was the discount code. Thanks, Phil, and good to see you. Long time, Phil Pierce. Thank you so much, Adam. Thank you so much for all the
Yeah,
attendees.
thank you
Really good
so
questions.
much. I'll get you the questions. Maybe we'll end up doing a follow-up session where we just do kind of a Q&A just on this
Sure.
topic, because there seems to be a lot of questions. So thank you everyone for joining. And once you get in the Slack group, I'll have Simo send over the slides, post any answers, any questions, and we'll post this recording. So thank you all for joining. And as always, Simo, thank you so much for sharing your wisdom.
Thank you, guys. Thank you, Adam.